What if the universe never truly began? What if time had no beginning? What if the Big Bang wasn't the birth of everything, but just one event in an infinite chain of cosmic cycles? The universe we see today is vast, ancient, and ever-expanding. But could it one day stop expanding, collapse, and be reborn again in another Big Bang? The idea of a cyclic universe, a cosmos that endlessly expands and contracts, has fascinated scientists for decades. One version of this idea, called the episodic model, suggests that instead of a singular beginning, our universe is part of an eternal repeating cycle. But how does this work? Could it explain the mysteries that the standard Big Bang model struggles with? And more importantly, does science back it up? Let's explore. The Big Bang. A singular beginning? The Big Bang theory is the leading explanation for the universe's origin. According to this model, about 13.8 billion years ago, the universe emerged from an extremely hot, dense singularity and expanded rapidly. Evidence supporting this includes the cosmic microwave background, CMB, the afterglow of the Big Bang, still visible today. The redshift of galaxies, showing that space itself is expanding. The relative abundance of light elements, predicting how hydrogen, helium, and lithium formed in the early universe. But despite its successes, the Big Bang model faces some unresolved problems. Problems with the Big Bang model. The horizon problem. Distant regions of the universe have nearly identical temperatures, even though, according to physics, there wasn't enough time for them to exchange energy and reach thermal equilibrium. The flatness problem. Why does the universe appear to have an almost perfectly flat geometry? For this to happen, the initial conditions of the universe would have to be incredibly fine-tuned, an unlikely scenario. The monopole problem. The Big Bang should have created magnetic monopoles, hypothetical particles with only one magnetic pole. But we've never detected them. To solve these issues, scientists proposed cosmic inflation, a brief exponential expansion that smoothed out the early universe. But inflation introduces its own complications, such as the possibility of an eternally inflating multiverse and the fact that it doesn't remove the singularity problem, it only shifts it further back. This is where cyclic models, like the episodic universe, come in. The episodic model, a universe without a beginning. The episodic model, developed by Justin Corey, Paul Steinhardt, and others in 2001, offers a radically different view. It suggests that our universe didn't start from nothing, but instead formed from the collision of higher dimensional brains, short for membranes, in a larger, higher dimensional space. Instead of a singular Big Bang, the universe undergoes endless cycles of expansion and contraction. Each contraction smooths out the universe, preventing chaotic singularities. Then, a new Big Bang-like event occurs, creating a fresh cycle of cosmic evolution. How the episodic universe works: brain collisions, the engine of cosmic cycles. According to M-theory, our universe might be a three-dimensional brain floating in a higher dimensional space called the bulk. Another brain, hidden from our view, exists parallel to ours. When these brains collide, they trigger a Big Bang-like event. The energy from this collision spreads across the brain, giving rise to the matter, radiation, and expansion we observe. Over trillions of years, the universe slows its expansion, contracts, and the cycle repeats. This model removes the singularity problem by ensuring that contractions happen in a controlled manner, avoiding the infinite densities of a true singularity. Solving cosmological problems without inflation. The episodic model solves the horizon and flatness problems differently than inflation. During contraction, distant regions mix and homogenize before expansion begins again. This explains why the universe looks so uniform without requiring inflation. The contraction phase also naturally leads to a flat universe, removing the need for fine-tuned initial conditions. Unlike inflation, the episodic model avoids the multiverse problem and doesn't require an arbitrary starting point. Scientific predictions and future tests. A good scientific theory must be testable. The episodic model makes predictions that can be checked with real-world data. 1. Gravitational waves. Cyclic contractions should create gravitational waves with a different pattern than those produced by inflation. Future gravitational wave detectors, like LISA, might distinguish between them. 2. Cosmic microwave background, CMB, polarization. Inflation predicts a particular pattern in CMB polarization. If the episodic model is correct, these patterns should be weaker or absent. New telescopes could confirm this. Could the universe really be cyclic? The idea of a cyclic universe challenges our deepest assumptions about time. If true, it means the universe has always existed and will continue forever, undergoing infinite births and deaths. But does this mean history repeats itself exactly? Probably not. While each cycle starts fresh, quantum fluctuations ensure that no two universes are identical. Each cycle produces new structures, galaxies, and even different possible forms of life. This concept resonates with ancient philosophies, from Hindu cosmology to Stoic cycles of eternal recurrence. Science, it seems, may be catching up with ideas that have existed for millennia. The future of cosmology. What's next? As technology advances, we may finally uncover whether our universe was truly born once or whether it's part of an endless cycle. Future research will focus on more precise gravitational wave detection to look for cyclic universe signatures, improved CMB analysis to identify patterns that distinguish inflation from the episodic model, deeper exploration of string theory and M theory to understand how brains interact. If the cyclic model proves correct, it would redefine our understanding of time, space, and the cosmos itself. Instead of a fleeting moment in a one-time universe, we would be part of something much greater, an infinite, unbreakable cycle of creation and rebirth. The episodic model presents a bold alternative to the traditional Big Bang theory. It eliminates the need for a singular beginning, solves key cosmological problems, and offers testable predictions that could reshape our understanding of the universe. Could we be living in one of many cosmic cycles? Could our universe collapse and give birth to another? If so, what comes next might not be an end, but a new beginning. Only time and science will tell. As you know, in one of the videos we discussed the general theories about the beginning and end of the universe, which you can click on above to watch. Now, do you think we are part of this cycle or not? Do universes have no end, and are there parallel universes? Be sure to leave your thoughts in the comments. I'll check them out. And what do you think about the origin of life and our DNA? Do you believe it originated here on Earth, or did we come from somewhere else to this blue planet?